Hi everyone and welcome to my new video. In this video I'm going to talk about MathMod's graphics user interface. MathMod graphics user interface is mainly made with two major windows, the left one and the right one. The left one is by far the most complex. Okay, the right one is the MathMod's viewer, which means that it's showing the result of all the equation, the mathematical equation, the texture that you're applying to your object and the different configuration that you are doing with MathMod. Okay, so the right one is just a viewer. The left window is the most important um, window for doing your mathematical work. So this video will focus on explaining what it means, what all that's the option that you have here, what are they for, and how they can help you achieve your work. Okay, so let's begin with the left window. So here you can see all the MathMod's integrated scripts. And here you can see that there are 377 integrated scripts. By scripts, I mean the objects or a collection objects that you can see in the right window. Okay, so each script can contain either one or more than one object, mathematical object. I will show in after that that MathMod can show more than one object in the same time. So each script can contain either a parametric surface or a collection of parametric surface. It can also contain an isosurface or a collection of isosurface, and also there are what we call pariso objects. Pariso objects are a mixture of parametric and isosurface. Okay, so pariso objects are the most complex objects that are supported by MathMod. Okay. Okay, I'm not going to go in detail about what is the mathematical definition of parametric and isosurface. I'm pretty sure you can find a lot of valuable documentation on the internet. Just Google parametric and isosurface, and you will see that there are dozens and dozens of very valuable and informative websites that talk about the intrinsics of each of these mathematical representation of this mathematical surface representation. They are quite different, isosurface and parametric, and they are the only two supported by MathMod. So MathMod is specialized in plotting parametric and isosurface. Okay, so like I said, there are already, you can see that there are already, you have 377 integrated scripts. Okay, and each script is can be can represent can include one or more many mathematical objects. Okay, so now before going in depth in showing some example of parametric and isosurface, I want to talk before that about this part of the um, the MathMod's graphics interface. Okay, just before that, there is a button here. Sometimes you don't need to show the list. So to hide it, you have to click here. Okay, when clicking here, you see that the collect the list of included scripts is hidden. So sometimes if you need a little more space in your screen or things like or web phone or tablet, you can just hide it. Okay, click one more time and it will show. Okay, so now let's begin with the model detail view. The model detail view is in fact just a view of the script. Okay, the script is a text based in text in text based format. So but it's in JSON file format. Okay, the JSON file format is widely spread and well-known file format that is very useful for storing data and things like that. Okay, so there are there are a lot of frameworks that can read and extract information from JSON files. Okay, so so here, as I said, the script edit is the one way of editing the scripts, MathMod scripts. Okay, so if you have small scripts like this one and small one and that contain one object like this one. Okay, so it might be easy to edit the scripts from the script editor. However, when you have a complex scripts that contains more than one object, mathematical object, then it will be very complex and very quite difficult to edit the scripts by using the script editor here. Okay, so this is when the model detail tabulation comes handy. The model details is represents is an easy way and of reading the scripts that you have here. Okay, for example, if I change here the x max, okay, to 6, you will see that, okay, here the x max is here. You see that it's that it's automatically reported in the model view, but it's easier to see here the domain definition, okay, than in the scripts. Okay, sometimes it's like I said, when you have small scripts, it's easy to use the script editor, but when you have complex one, it's very useful to use the model detail. Okay, so when you make your change in the script here, it's automatically reported in the model detail. Okay, I will just show you once more. Okay, so here you can see that it's now 8. Okay, here also you can edit your scripts. Okay, for example, here 9, if I change the x max to 9, when I render it, okay, in the script itself, you see that MathMod has automatically rendered a new script for you with the right x max value. Okay, so it's you can edit your script either from the script edit, okay, from here, or from here, from the model detail view. Okay, so in this script, for example, we defined a constant c also, that is 1 by how much? Well, yes, 1 million. Okay, so here also you can see that constants are defined here. Okay, so here also you can see that automatically the model data can show you the constants included in or defined in your script. Okay, so this model detail is very useful for you to if you want to edit, either to edit or create new scripts. Okay, so now I'm going to move to the third MathMod tabulation from the from MathMod graphics user interface. It's called the view control. Okay, the first tab, it's for the CND. CND is the is condition that you can impose to your model. So basically, it's a way of showing, the condition is a way of showing the intersection of your model with another mathematical object. Okay, for example, here with our object, I'm going to add a CND condition just to show you um, how it works. CND. For example, I'm going to add the condition x plus y plus z, which is a plan, the equation of a plan. Okay, so as you see here, when you render your object with the CND or condition, MathMod will show the intersection between your object and the CND. It doesn't show the CND itself, but it shows just the intersection. There are you can of course add if you want, you can show the condition itself. In our case now it's a plan. Okay, but I will let this for now. Now just we want to see the intersection between the plan, our condition, and our object. Okay, mathematical object or expression, the one that is represented here, and this its result that is here. Okay, so the CND is a way of choosing which part of the objects you want to see. For example, here it's the CND. You can CND is the part of the object that verify the condition. Okay, that verify the condition x plus y plus z superior to 0. Okay, so if you deactivate this button, all the points the 3D in the 3D space that verify the equation x plus y plus z superior to 0 will be will be hidden. Okay, we will see this. Okay, so here you can see that all this part, the upper part of your object is not shown anymore because we deactivated. We choose here to not see them. Okay, you can also choose to hide the other part of your object, the part that's all its points, 3D points, doesn't meet the requirement, mathematical requirement of your condition x plus y plus z. Okay, if you deactivate it also, so we are left with uh, the intersection between the plan x plus y plus z and the object itself. Okay, so the white circles are in fact the intersection. Okay, so you can also choose to show the point that verify the condition as a mesh. Okay, so here they are. Okay, and choose you can make all the combination you want, in fact. So here the mesh are the part that verify the condition. Here they are the filled triangle that don't meet the requirement of the condition, mathematical condition x plus y plus z. Okay, so you can also mix the mesh and the other, so you can hide also the the border. So you can make a lot of combination from with this part of the graphics and the graphics user interface, MathMod graphics user interface. Okay, so but it's still not useful unless you are using a condition in your script. Okay. So let's move to the other part of the view controller. Sorry. So here we have the rotation. Rotation is a way of controlling the animation made by a rotation. Okay, to rotate, to animate your objects with rotational movements, all you have to do is to tape Control and A. Okay, Control A to stop, Control A to launch the rotation, Control A to stop it. Okay. However, with Control A, you are launching you can start and stop the rotation. After that, you can control with your mouse in mouse the speed and the direction of the rotation. Okay, like what I'm doing right now. Okay, right, left. You can increase the speed with the rotation. So, okay. Um, However, here we are using what we call x plus y plus z, which is a mouse controlled rotation. Okay. Sometimes we want our object to rotate around one or more than one axis. Okay. For example, if you want your object to rotate around the x axis, so it's quite difficult to do it with the mouse. Okay, so what we are going to do now is to stop the mouse controller the rotation. Okay, so you see that it stopped moving. It stopped moving. Now we are going to the x. However, it's not even when activating the x rotation, the rotation around the x-axis here. Okay, it's not moving because you have to give the rotation of value. Okay, the biggest you see that now it's starting to rotate around the x-axis. Okay, if you you can increase the speed of rotation here, okay. You can also give it an inverse rotation, okay. So you can control here it's you are controlling the speed and the direction of the rotation, okay. You can do the same with the the xy, the y axis also, and z. You can also combine the two or more, okay. So here we are combining two rotation x, y. You can also combine you can also add here the x, y, z controlled rotation. However, it's going to be quite difficult to understand exactly what kind of movement when you have more than one. It's quite difficult, okay. So this is a handy way of doing some controlling your animation, okay, or rotation animation, okay. So sometimes you have to init the rotational value. I'm going to talk about this later, but it's not very important right now, okay. But sometimes you have to re-init the re-init the rotation value, okay. So right now, if when we okay, so now I'm going to talk about the time step. So the time step here that's shown here is for the parameter t that you can introduce in your object in your equation for controlling the morph effect. An example of objects with the parameter t, I think this one, no, yes, this one, for example. Yes, here in its equation, yes. I want to show you a simple example. Yes, you can see, for example, here that we have introduced a time a parameter t, which means time, okay. So object like that, you can you can apply some morph effect on them to see the effect of introducing the time parameter here in the equation of this example. You have to activate the morph effect with P, Control P. Okay, so here I'm activating it. Control P to deactivate. Control P to activate. Control P to deactivate. So when it's when you use the time the parameter t, you can increase the steps between the time how the time parameter you can control the flow of the time parameter here. So I'm going to show you that when I decrease I decrease the time, the lapse of time between each frame. So you see that it's slowing down. If I increase the steps between each if I increase the flow of the time, you can see that it's moving very fast, okay, like here, okay. So this is the time step is for the t parameter, okay. So here you can control the flow of the time, okay, the parameter t, which is parameter for time, okay. We will discuss more about this in another video, okay. So now I'm going to stop this this animation. Here the export skull. This part is for the if you want to export your object as a mesh. Okay, so with MathMod you can export your mathematical object, and here sometimes before exporting them, if you want to scale them, okay, in, for example, here in the axis, if you want to that your mesh will be scaled along the z, the axis z, you can increase the scale factor here from 1 to 2 or 3 or what you want. You can make any combination you want. Okay, sometimes I was some users asked for this feature, so I added here since I think the release 10.0. Okay, so this part is for the mesh exportation. Okay, so scale factor for exported mesh. Okay, so now we are moving to the appearance. Appearance is for mostly for choosing the color and applying some texture to your object. Okay, the first tabulation is colors. So mainly all our objects are made of two main of are made are colored with two colors. Okay, one for the front surface, okay, and one for the back surface. Okay, and another one for the grid. The grid is the mesh that you can see here. Okay, so we can choose to change the back surface. For example, here it's the green one. Okay, the anterior surface has a color. It doesn't change like you see here because you are changing only the front surface. Okay, so you can apply the color that you want. You can also apply the transparency factor, so your objects will be transparent. There are some artifacts, but it's still nice to see transparent objects. Okay, so I'm going just to okay. Here we are changing the anterior color of your objects, the same as the front surface. Okay. Here the OpenGL front surface support. This is for some sometimes there are some some graphics card that have some problem with MathMod viewer. Okay, with MathMod OpenGL viewer. So if you have some, if you can't see if when launching MathMod, if you see that your the mathematical object that is shown at the beginning of MathMod, if you see that you have a dark color, you can try to deactivate this button. Okay, so this button is a very special one. It's made for some graphics card that have some bugs. I think it's not from MathMod, but really there are some graphics card that have some bugs when rendering OpenGL when using OpenGL library. Okay, so here texture, I'm going to, okay, here texture, you have you can apply some texture to your objects. You have some included example, for example here. Okay, if you want to see the description of this script, you have it here. For example, you can make some different, you can change, modify it, and see the result. Okay, so here, so you can see in real time the when you apply this texture on your object. So I'm not going talk in detail about the texture and noise and things like that. We'll let this for another video. Okay. Here you have texture, but you can also apply what we call a pigmentation. Okay, pigmentation, it's a special kind of texture. Okay, so here also you have some really nice example of pigments. Okay, okay. So this now we are going to move to specular. Specular is for the lightning of your object, how you want it to be. Okay, how you want it to be. If you want to increase the amount of the light that is shining on your object. Okay, so here it's the shininess. You can increase, decrease the shininess. So you can play with this tool. Sometimes you can have some really nice result when playing with this, especially if you want to show some metallic effects on your, if you want to apply some metallic um, uh, effect on your 3D object. Okay, so here also it's the ambient lightning, so you can also increase, decrease, change a lot of there are a lot of parameters to control the ambient um, the ambient lightning. Okay, and also the diffuse. There are also what we call the diffuse, the OpenGL diffuse effect. Here also it's another OpenGL effect that you can control from this with this tool. Okay, so there are a lot of visual effects that you can control directly from MathMod with the MathMod graphics user interface from the appearance. This is what we call it, the appearance. Okay, here thread, it's not really it doesn't relate to the appearance of your object, but we put it here. Okay, so it's not the best place for it, but right now it's here. Okay, so here it's the for the thread. The thread is the number of process or thread that you want MathMod to use on when rendering when rendering your objects. Okay. By default, MathMod will always look for the best number of threads that are supported by your machine. Okay. For example, with my Mac Mini 2014, I have a Mac Mini 2014 with double core and 4 thread. So automatically my MathMod had detected that I can use 4 thread. Okay, but I can increase the number of thread as I want. Okay, so here for example I can use 8. Okay, you will see that now when I recalculated my objects, I used eight threads. Okay, it's not useful in my case because 8 threads are not my machine only um, uh, uses can use 4 threads in the best case scenario. Okay, so 8 mm, I can use them if I want, but there will be not too much difference in the speed of calculation. Okay, so here you can calculate, you can use the amount of thread that you want to allocate for MathMod. Okay, okay, so it's up to you to let MathMod choose the best number of thread, or you can set it from here, or from the also you can also set the number of thread from MathMod configuration file. I will show you in another video how you can configure how you can use MathMod configuration file. Okay, so there are a lot of options that you can set in MathMod configuration file, and one of them is the number of thread. So now let's move to the sliders tabulation located here. Sliders are useful for some special scripts that define parameters that can be um, modified on the fly. Okay, I will show you an example. For example, here we have the planar enipper. Okay, the planar enipper is a parametric surface with some constant C, K, E, K, L, X, Y, L, Z, U max, U min. Okay, so here we have defined some sliders. The sliders are located here, corresponding to each parameters, to each constant defined in this script. Okay, you can add other parameters even if they are not defined here, but this is another topic. We will talk about this in another video. Okay, but as you can see here now, we have some constant, and we wanted to see the effect of changing this constant on the shape on our parametric surface. For example, the constant, the parameter key, if you change it, you see what's the result. Okay, here we have another parameter. Okay, so we can play with this, so you can see that we can see the effect in real time. Okay, this is very useful if you want to if you are looking for new objects and good looking object. Okay, so here we have a good example on how you can modify the parameters and see the results on the fly. Okay, what's more interesting is that when you are working with the sliders, if you want to save this configuration, you can add it. You can click here on the add. Okay, so now here you can see that the last configuration is saved automatically here, and also it's saved in your here in your script. Okay, so next time so you can't lose it. Okay, so you can save each configuration that you have discovered from your by modifying your parameters. Okay, so this is the sliders are very good in changing the parameter included in your script. Okay, so it's you don't have to make some changes from here from the script or some things like that. You can do it very effectively by modifying the parameters from the sliders. Okay, and moreover you can save the result. Okay, in in your script. Okay, so this is just an introduction to the sliders. There is a lot of there's still a lot of point to clarify in this section, but for now I'm just giving you an overview of how things work with MathMod. Okay, so I think I finish my this will finish my the first part of this introduction to MathMod's graphics user interface. I hope you enjoyed it, and see you next time in the second part for concerning the graphics user interface, the concerning MathMod's graphics user interface. Thank you for your time. See you in my next video. Bye.